it is that you are. We are here, Quarkus Insights, episode 199, just one shy of 200. Look at that. We're going to talk about RESTeasy Reactive, although I'm not sure, we don't really call it RESTeasy Reactive anymore, right? It's just the Quarkus REST implementation, right?
Yes. Yeah, the new name is Quarkus REST, and now we don't have much. Well, we don't have too many occurrence of RESTeasy Reactive, except in the package name and a little bit in the code. But yeah, because we didn't want to break the world. But no, it's Quarkus REST. So we should redo that slide with number 200. Okay, 200. What's news in Quarkus REST?
There we go.
199. What kind of HTTP status is that?
I don't know. That's
Actually, I'm not even sure it exists.
Yeah, I don't think so.
All right, so let's talk a little bit about, before we get started here, some news. We've got some news, and I'm going to bring up this little screen share here. So this is just a Quarkus blog site. So we released 3.19.4. Like when's 3.20 coming? Is it next week?
Yeah, pretty well. You can check the wiki where we have our release planning. It should say exactly when it is.
Yeah, so 3.20 would be the next LTS. That's coming along.
Yep.
So we look at the Quarkus wiki. I'm not going to go there right now. So we've got 3.19.4 came out last week. Some minor stuff in there. There was this really kind of cool blog post from Orange that came out yesterday that Thomas had written, talking about Quarkus and telco capabilities at Orange. And especially talking about Spring to Quarkus. They were a big Spring shop moving to Quarkus, and the journey that they took. And this is, I think, something that we're starting to see more and more, right?
Yes. It's a great blog post because it shows how Quarkus can be used in edge environment and what does it bring, and how the velocity you have when you start working with Quarkus, and it's a great success story.
Yeah, we seem to be doing pretty good with telcos.
Yes, yeah. And Orange, it's I'm not sure it's still the main French telco, but it's a very big one. It's a historic one.
Yeah, and they seem to be doing all sorts of new cool stuff too. I mean, it doesn't seem to be just legacy stuff. It's
yeah. Well,
5G edge stuff, really cool.
Yeah, my internet today is Orange typically. So if it breaks, that's their fault.
All right.
And speaking about the releases, so the full platform release of 3.20 will be cut on the 26th, so in 2 days, and that is the new LTS. So
yeah, cool. So the next long-term release supported version coming out this week. That's awesome.
And the next one will probably be 25, and that should be September-ish, something like this.
Sweet. All right, so let's dive into REST. What's new with REST stuff? I know some of the stuff, so I've got a little sneak preview, and some of it's pretty cool, like the serial. Hopefully, you're going to talk about the serializers and no more reflection and all that fun stuff. So, So what do you got? I think people know you. You probably don't have to introduce yourselves, do you?
Oh, I wouldn't fault them if they didn't. So that's fine.
All right, so you guys go ahead and introduce yourselves.
Go ahead, Clément. Seniority first.
All right, so I'm Clément. I'm the co-lead of the Quarkus project. I'm part of the project for almost the very, very, very beginning. I'm the one that has pushed Reactive a lot over the past couple of years. So, and here today we are going to talk about the latest improvement and enhancement we did around Quarkus REST. But Quarkus REST, the whole idea was how to build REST stack, an HTTP stack, a REST stack on Quarkus that embrace the reactive core we have underneath. So to have better performance, less resources, and better on the cloud, more scalable, and so on.
Mm-hmm. Yeah, Georgios, whatever. I wasn't in Quarkus from the very, very beginning, but at this point, it's been like so long. It's been, what, it's been 5 years since Quarkus was released, so I've been part of most of that. I, along with Stuart and Stefan, we implemented what was initially called QRS, then Quarkus REST, then RESTEasy Reactive, and now we're back to Quarkus REST. So hopefully that name will stick. Yeah, and so the reason, so just to give a little more history here, the reason we wanted Quarkus REST, or at least a new stack based on REST, was that the existing RESTEasy stack that has been around for well over a decade by now, which is the one that's used in Wildfly or JBoss DAP, whatever, to implement the REST stuff, and it passes like the full battery of TCK and all that stuff. That's a great stack. I mean, it's really good, but we needed something that embraced two different principles that are fundamental to Quarkus and that couldn't be easily retroactively adapted by RESTEasy Classic. Those two principles are build time optimizations of the stack, because as you see, like Quarkus REST and most of our stuff makes heavy use of annotations to make things like super easy to write for developers and all that stuff. So all that metadata that's built up with Quarkus REST, we want to do that at build time versus runtime, which the RESTEasy stack and like almost every other framework out there does. So that build time one. And the second thing is what Clément mentioned, to embrace the reactive core. So we wanted to build a REST stack on top of fully non-blocking Vertex stack, which we did, right? But again, like this is a point that has caused so much confusion, and we'll try and make it as clear as possible here. You don't have to use reactive programming when you use Quarkus, right? When you use REST or messaging or anything else, you don't have to use reactive programming. The core itself is reactive, but you can run your stuff on worker threads, so everything can block for as long as possible and all that great stuff. But by building on a reactive core, you can essentially take advantage of the extreme scalability that the hardware offers if you actually need it, right? So if you actually need to take advantage of the hardware as much as possible and squeeze as much performance as you can out of it, then you go non-blocking reactive. And that's not possible to do with a stack that's built initially as a blocking on top of blocking IO, right? So that's where Quarkus came from.
You can do blocking on top of non-blocking, but you cannot do non-blocking on top of blocking because that doesn't make any sense.
Yes.
And
exactly.
And what we did in Quarkus REST is to actually really keep the reactive core and then offer you three different execution models, going from the traditional imperative model, so blocking thread, the thing you have been using for the last 15 years or 10 years. And that's still what we recommend today, because even with that, we have 30%, even more of performances, because all the networking part is handled by the reactive core of Quarkus. And we optimize up to the dispatching, and then, you do your thing. Then we have the virtual thread story, which so the problem with the first strategy is that you're limited in your concurrency is limited by the number of threads you can have. And on the cloud, if you have very small machines, your number of threads is going to be quite limited because thread means memory, means CPU, and things like that. So virtual thread allow you to remove a little bit that limitation by using a few number of platform thread and potentially infinite number of virtual threads. However, there are still limitations, so don't believe it's really the thing you need to use. My series about using virtual thread in Quarkus is still very valid. I need to revisit a little bit with Java 24, which got released last week, because improved a little bit the pinning, but we still have the native story. We still have a lot of things and monopolization issues. But it's getting better. And then if you really want 20, 30, 40,000 requests per second, then you can actually use a reactive execution model with a reactive development model. That's where, yeah, as Georgios says, that's where you will squeeze the most of your performances. But not a lot of applications need to reach that level of concurrency. Like 30,000 requests seconds is a lot more than many of the applications that are running today. So yeah. So yeah, and last thing is you have the choice between these three, but you can mix them.
Yes.
Like for example, your health needs to be non-blocking because maybe the rest of your system is going to be overloaded and full, but you don't want the health checks to say, oh no, you can't be executed. So you can, for example, say, okay, the health checks will be working and will always have the resources to run. Or that part, our landing page is hit like 30,000 requests per second. So yes, that part we really need to have it full reactive, but the rest, interacting with the database and things like that, no problem. That is a lot less concurrency and you can decide. And today, Quarkus REST and Quarkus REST is the only framework out there that is able to give you that flexibility. One stack, three model, mix as you want.
Exactly. Yeah. I think that's the key, right? The framework provides you like all the capabilities, but you as a developer get to choose like and to mix and match inside the same application what you want to use, right? You don't have to make this choice up front, which you have to do in some other stacks out there. And it's not great when you have to do that, right? Now, so we can see my screen, right?
Yep. Can you make the font a little bit bigger?
Bigger, okay.
Yeah, a little bigger. At least the code part. There is a question out there though, and I don't know if you want to tackle it now or later. Talking about hot reload. You know, is it tied to Quarkus REST or can you trigger it on save? You know, Stupendous like, Follow is saying he's got long reload times because of lots of extensions. If you could trigger it on save, it would speed his workflow up, his or her workflow. Sorry, I don't want to assume gender.
Yeah, go ahead, Georgios.
Yeah. So we don't have it on save. Like theoretically, you could do that. What we have now is that it's triggered on like some incoming request, right? Whether that's HTTP or messaging or something like that. Now that said, right? The fact that you do have a lot of extensions and that causes like a high reload, that might be something that we need to look into because as part of this, the Quarkus REST thing, we have a contributor who's done other stuff too, which I'll mention later on, who was actually looking into reducing the reload time of Quarkus REST when there were a very large number of sub-resources. So I'll talk about what sub-resources are later. They're like a not very popular feature, but they're heavily used in Keycloak, right? So if you have the Keycloak admin client, that like has hundreds of sub-resources, and it can take like a few hundred milliseconds to restart those. Now, well, we have this awesome contributor, Post Ramus, I think his name is, who actually wanted, he was using the Keycloak admin client, and he's like, yeah, well, this takes too long. And we're like, okay, yeah, you're right, but we're kind of swamped now with other stuff. We'll look at it at some point. So he took it upon himself to fix it on himself by his own, right? So he started profiling it, and then he found out a bunch of places where it could be improved. And I think he improved it by probably like more than 30% or something like that, live reload time. So my point is that if you have examples of this, where you have like an application, which like with a combination of our extensions, or like you have a lot of code and things are slow or are slow to reload, it would be great if you could like upload an example of that to GitHub, and either you or we take a look at it and profile it, because there absolutely are things to be done to improve live reload time, because we have almost like for all our, let's say, obsession about performance and keeping things like tight and footprint low, we have spent very little time optimizing the live reload time, right? Because in almost all cases, it's good enough, right? So we haven't spent a lot of time, but that doesn't mean that we shouldn't, right? So this is exactly where we want feedback for people saying like, yeah, this doesn't work as it should, and we will definitely take that into account.
Yeah, so he followed up and said, it mostly comes from Liquibase because it's running the migrations on every hot reload. Let me ask this, and maybe this is a dumb question. There's that, there's a switch in there for instrumentation-based reload. What is that, and would that help him or her out?
No, well, if all the slowdown is coming from liquid base, that would not help, right? So I assume that what you need to do is like, I don't know, turn off liquid base on every live reload or something like that. But what the instrumentation thing does is it doesn't restart Quarkus. What it does, it uses the JVM's instrumentation API to be able to swap out implementations of methods with new ones. So it only works under certain circumstances. And it didn't even work properly when we tried it. Like there were weird corner cases which we never figured out, like why it didn't work as it was advertised it would, and that's why it's not the default, right? But in this case, I don't think it would make any difference anyway.
Yeah. So I guess the follow-up question is, is it possible to do it like that's something that they can do so that it triggers on save or some other thing other than an HTTP request, or is that not currently possible?
It's not currently possible as far as I remember.
No, but it's not the first time we hear about that Liquibase issue, and yeah, Liquibase is not great at dev time. It's and even at startup time, it can really be taking a lot of time. We need to find alternatives.
Definitely, yeah, definitely. Okay, so just a quick reminder of like what the general API of Quarkus Jax REST, Jakarta REST looks like, right? The big idea about the API is that you have annotations, and you can like just add annotations onto what methods that like look like business methods or whatever, and this will handle all the input and outputs of HTTP, right? So no weird interfaces to implement or like weird abstract classes or bad API stuff like that. The general idea of the API is amazing, right? Just annotate with like path, get stuff like that, and it just works. So for example, if I
can you make the fonts a little bit bigger, Georgios? I'm sorry.
Even bigger, man.
Yeah, I know. When I do this, my screen's like yay big that I'm trying to do. So one last question just to tie out that other conversation. Would Flyway be any better or in the same boat?
I don't know.
It will be the same. Well,
I think
it's the same thing. Its database migration is just like crazy. It's generally better in dev mode to actually prepare with the right version of your schema and then forget about it and disable Flyway or Liquid-based for dev mode.
Yeah, exactly.
I'll say too, like with the REST stuff, one thing I love about it is the goal is not to force you to use Quarkus stuff, right? So if you like go back and you look at your imports, I don't think you have any Quarkus specific imports. They're all to the Jakarta RS spec.
Yes,
right?
Here, yes. But that was going to get me to my next point, okay? So just like to show this in action, like with you, I'm using like IntelliJ's client here because it's so easy to use. You just like hit the endpoint, it returns JSON, whatever works, right? But now here's to my other point, right? So for all the greatness of this API, which it is, this API from Jakarta is horrible, right? This one is just terrible. Like the way you write filters, for example, is terrible. And it's terrible because, like, first of all, okay, you have to implement this, right? That's not terrible, but in addition to that, you also have to annotate it with provider. And then the method that you implement, which takes a context object, does not even have all the information you usually need in order to implement whatever you need to implement. So then you have to figure out, like, okay, yeah, well, I need to like start injecting this other weird context stuff, which I have like no idea where I'm supposed to get it from, right? So this is like an example of a bad API. This is where I think, well, I don't know any of the history of how Jakarta REST came about, but like the resources API is wonderful, but like the filters and like other stuff that looks like filters, this is like really bad. So in Quarkus REST, what you can do is you can write filters like this, right? So you have like a very similar API to the one for the resources, where you just annotate a method with this. This is a Quarkus import, so it's a Quarkus specific thing, and then you pass information into you pass parameters into the method, which you know how to find which ones they are, because like if the source, the Java doc tells you what you can use. Now the other thing with this is that you can also make this non-blocking, right? By returning like a uni of void, you would make this non-blocking, right? Because you might want your filter to be non-blocking as well, as opposed to blocking, where if you just make it void, it blocks, right? So that's the other thing I wanted to say, that with Quarkus REST, well, the fact that we did Quarkus REST gave us a lot of flexibility in what new, like, or improved stuff we could do, right? So that's one thing. Now, let's go to the execution model we talked about earlier, right?
Yeah, one thing, Georgios.
Yes, go ahead.
The original JAX-RS code for container for provider and things like that is directly inspired from, well, it's directly inspired from what they were doing in servlet at that time. So that's why there is, when you look at that code and when you develop with servlet, you say, oh yeah, it's pretty natural. But we are in 2025. And so, and HTTP has evolved a lot. A lot of things have. So now we are speaking about HTTP 2, even HTTP 3. Things have changed a lot. And asynchronous first, WebSocket and things like that. So that model, well, show its age, more or less. Like it's come from the early 2000s. Yeah. So that's one of the reasons. And one of the work, like you did in Quarkus REST, is actually, well, how can we modernize that API to have something more meaningful, much more modern, and that contains the info we need these days to do what we need to do in a filter.
Yeah, exactly. And I should say that we use this stuff internally in Quarkus everywhere, right? Well, not everywhere, but in a lot of places. So this has been tested extensively by us as well. And the other good thing, now that you brought HTTP 2 and 3 up, now the huge benefit that Quarkus has, that the fact that Clément in like, what was it, 2018 or 2019 pushed for Vertex everywhere, that's going to like pay off. Well, it already has paid off massively, but it's going to pay off even more in the future, because when Vertex starts supporting HTTP 3, which as far as I understand, work is already underway, Quarkus will almost automatically pick up that support, and you don't have to do anything. Which, for example, now, like
almost with quotes and
almost. But I mean, we don't have to do a ton of work to make it work. We don't have to like implement all the spec on our own, right? Like HTTP 2, it just works on top. Quarkus REST with HTTP 2 just works, right?
Yep. Yeah, you can even use a feature like push and things like that. It's all there. And HTTP 3 is a Vertex 5 feature, not 5.0, probably 5.1. And we are already considering updating to Vertex 5. We will start the work at the end of this year, and to have something ready next year, so 2026. You may think that it's a long time, but yeah, well, we have a couple of other things that are more urgent to do right now. And Vertex 5 is not yet fully, well, it's not GA yet, so we are waiting for it to be GA before starting things.
Here's another question here. So any plans for standardized error formats like RFC 9457?
There is an extension for that, no? In Quarkus.
There is, but it has come up again recently, and like Stefan was wondering whether we should actually incorporate that into Quarkus itself, because there were a ton of people asking for this, and there seem to be a ton of people using the extension too. So that probably
didn't I do it for reactive routes? I think I did something similar to that for reactive routes. So yeah, if we do it for one place, we probably should standardize on that. Yes.
Yeah, it does make sense for sure. Absolutely. So like again, like REST might seem like, oh yeah, this problem has been solved, but do you see how many new things that come up all the time, right? So there's always more work to be done here. Now, okay, if there are no more questions, we can go to this the execution model thing we were talking about earlier, right? So, like Clément said, you can mix and match like standard blocking, non-blocking with reactive types, or virtual threads, right? In the same application. So let's see how that actually looks like, right? So the first one, I'm just saying, okay, return in all of them. Actually, I'm just saying return the thread name. So if I go to not here, generated requests. If I go up here and here, execution, if I go to execution blocking, I will get an executor thread. If I go non-blocking, I will get an event loop thread. And hopefully if I do uni, I will also get an event loop thread. I did. And if I go to virtual threads, I will get a virtual thread created by a Quarkus specific factory, right? And now,
I can explain that.
I'm going to tag you in this one.
Yeah, so the thing is, if you use virtual thread, you may be wondering, hey, how do we get that name? Normally, virtual threads are unnamed. However, when you start debugging virtual thread stuff with several virtual threads and you have no names and the debugger just have nothing, just very, very bad. And it's also bad inside your logs because the thread name is actually not even written. So you have the ticks and nothing in between. So we decided to say, hey, no, we have to name them for just to be more convenient. You can control that. You can change the prefix, but yeah, we do name our virtual threads. We do not pool them, so there is no thread pool with virtual thread. We just give them a name.
Yeah, so if I hit it again, like 1, 2, 3. Yep. Whereas, for example, if I go to the like the non-blocking one, I will keep on reusing the event loop, right? So there's only 2 event loop threads here because like there's no real traffic, so we just keep on reusing them, right? But like so virtual threads, we don't reuse them. That's the whole point. You're not supposed to. You get a new one every time.
If you run the same thing from your browser, you will stay on the same virtual thread because the connection is sticky and will be associated to one virtual thread. But because you use curl, then it will get a new connection every time, and that's why there is some load balancing in terms of to have several event loops. So you can see an event loop for one CPU core, more or less.
Yes.
There are rules on how we dispatch them, but yeah.
Exactly. So yeah, if I hit it in the browser here, I should get the same one every time. Well, let's make this a little bigger. Yeah, so in the browser, yeah, we get the same one every time because it's the same client, like we said, connection sticky, all good. Works as you expect it to. Okay,
except if you configure keep alive to be false, and then you will get a new connection every time. But don't do that. Otherwise, you will have to redo the uncheck.
The whole idea with like HTTP 2 and even more 3 is to eliminate these new connections, right?
Yeah, HTTP 3 is even pushing the limit a step ahead because even when you are roaming and switching from, for example, from Wi-Fi to cellular to back to Wi-Fi, you will keep one single connection. Yeah. And that's great because you will be able, for example, if you do the TLS uncheck once, then you can keep it for days, more or less.
Yes.
It can lead to security issues because typically, how do you renew your JOT token or your TLS certificate and things like that? So we will need to think about that when we build protocols and application using it. But yeah, the keeping the same connection for days is just like super cool for me.
Yeah, it's a massive bandwidth saver time. Well, not bandwidth, but like latency saver, right? CPU saver, cool stuff. So again, in a few years, like Quarkus REST from HTTP3 will just work, right? Maybe even next year.
All right. So here's another question for you. So do we do things lazily? So like when the first HTTP request comes, is everything getting initialized lazy? Like why is the first one seem to be slower?
When we're talking about everything, well, it depends on what you mean by everything. So the only thing that actually gets initialized lazily are the beans, the CDI beans. Everything else is put in place by Quarkus when the REST stack starts, right? So all the metadata has been collected at build time, and then like the structure, everything that's like the infrastructure that you need in order to map HTTP requests onto business methods, that is actually all created at startup time. The only thing that gets generated lazily are the CDI beans that implement the various parts, right? So the stuff you can inject, basically, all that is implemented by CDI lazily. Does that answer the question?
Thing? Yeah, in dev mode, don't forget that when you do a new request, then you have the full dev mode happening. So that's why generally people say, oh, but it can be slow. No, yeah, but we started the full application. So
yeah,
when you think about it, it's not that slow.
That's a very good point. Okay, so if I do MD package skip tests, let's see how fast this starts up in production mode. So this is just an application with only Quarkus REST and REST client, right? So let's see, target Quarkus app, Quarkus run, and up. Sorry, there's something still running there. Let's kill it.
He's saying they're testing in production, like woo. No, kidding.
So this started on
Hibernate, and Hibernate will establish a connection. We acquire a connection from the connection pool, and that connection will be established at runtime. And there is we don't want to do that beforehand. So that may explain it.
So this application, so there's like a full REST stack and a full REST client. This starts on my machine, which is actually, it's pretty good, in 460, 470 milliseconds, right? So less than half a second for an entire REST stack. Oh, with Jackson too, right? So Jackson is pretty heavy. Yeah, at least at startup time. So that works. That works pretty well. But like dev mode, obviously, dev mode is slower. I think if I do MVN Quarkus dev, let's see, excluding all the Maven stuff, it takes 1.7 seconds, right? So dev mode has to do a whole bunch of other stuff, like so it takes a lot longer, right? Okay. Let's move on a little because we have some stuff to cover. Okay, so the sub-resources thing, like we had various problems with sub-resources, still have a few, but because we have awesome contributors, like I said, Post Ramus earlier, who uses this sub-resource stuff a lot, he made a bunch of fixes, and now you can like pretty much like use sub-resources in the same way you would expect to use like regular resources. What sub-resources are, they're a weird feature in JAX-RS where instead when you like have a path but you don't have like an HTTP method, like a get or a post or whatever, when you don't have one of those, you can return a class, like in this case, like this order resource thing, that itself can either have you have get and post on gets and posts on methods, or it can go even deeper and you can like go down, keep on going down like recursively until at some point some method implements get and is annotated with get or post or whatever, right? And in this whole hierarchy, you can keep on injecting stuff everywhere, either as methods or as fields. That didn't used to work really well, but now it does. So really awesome to see this stuff working now. If you want to see this,
yeah, Georgios, why is it useful? It allows you structuring your API with different classes implementing each part of your API. So if you have a very large API
yeah,
and you want to divide it, which is not necessarily possible with a plain with a single Jakarta REST or Quarkus REST resources or Jakarta REST resource, then you can use sub resources to let you do that. So
yes. So
that's
that's exactly what this example does, basically, right? There's a store, and then there's an order, and here we can see a bit like there's store, and there's order. So we're talking about order 123, and like then there's a position. So if you hit this, for example, then you will make sure that like you get the order ID, then you get like the position ID, and all that stuff like just works, right? So like Clément said, you can like recursively build up your API, but it poses a lot of problems to how this is implemented. And now, like this was just an example of something that was fixed. There are more stuff that have been fixed. So this is it's really cool to see like contributors take up stuff that we either don't have like enough time for, or have stuff on like lower priority because like just we don't use this. For example, like I've actually never used this in real life. I know Keycloak makes extensive use of it, so it obviously makes sense to have. Do we have any questions about this?
Nope. I'll say I've never used it before either.
I used it a couple of times, but in former lives, and yeah, I had a very, very large REST API, which was more or less HTTP based RPC, but whatever. And yeah, in that case, yeah, it was useful. No, yeah, it's not a feature that is used a lot, but when you have a very large application like Keycloak and a very large API, then yeah, this is a lifesaver.
Exactly. Okay, so now let's move on to something reactive, right? This is just a small thing, but again, it came from the request came from the community. So I just wanted to show like how cool like Quarkus REST can be because it embraces the reactive stack completely, right? So here, what do we have? We have a resource that returns a uni of string, right? And let's say this, like, let's pretend this does some useful work. Let's say like it goes to a database or whatever, right? Doesn't matter. It's something that can potentially be slow, right? And we're simulating that slowness by saying that, okay, when you by saying that, give me back the value after 10 seconds, right? And then when you get that value, just like log it, or if you cancel, log that too. But so in real life, right, this would be a pipeline let's say would be comprised of like, I don't know, a few different steps. And let's say like one of those steps is really slow, like getting stuff from the database is really slow. But you don't want, if the connection goes away, which means the client that asked for this data doesn't want it anymore. It went away, essentially saying like, I don't want to wait anymore. Then it doesn't make sense to execute the other steps, right? Because that'd just be a waste of time, because we'd be burning cycles to return a result that is never going to be returned because the user isn't even there anymore. So with go ahead.
It goes even further, because while it's not totally working like that today, and we need to improve a little bit, but imagine that you want to do a database and you acquired a connection, and that connection you acquired it, but that connection is a scarce resources because you don't have a lot of connections. And imagine that it does a big query taking a lot of time and things like that, and then the user cancel. If you continue that processing till it's come back, while you are using your connection for way too long for something which is completely useless.
Exactly.
So what this allows you is to actually save these resources. As soon as there is cancellation, you can say, oh, cancel. I'm going to stop what I'm doing and clear all resources. The connection can be used for someone else.
So going back to like your HTTP conversation, so you think about like your mobile phones, you move from Wi-Fi to mobile, you've essentially changed your connection, right? So
with HTTP 1 and 2, won't be
with HTTP 1 and 2, and that happens all the time. You float between Wi-Fi and cellular all the time, so it's not an uncommon use case.
No. Or imagine I'm working a lot on the train, and believe me, my internet connection on the train is not great. So yeah, it's
Yeah, so here, like if you use like IntelliJ's client, like I was using earlier, IntelliJ's client actually doesn't cancel the request, right? Because here we're going to see that it will actually show up. The result will show up. I'm pretty sure, at least. Yeah. So what happened here is that I pressed stop. I pressed stop on the request I made, but IntelliJ's client didn't actually like close the connection. I don't know what it did, because the result did show up. But in a proper client that does close the request, like here I'm using HTTP, if I hit it and then cancel it, then we actually see that the uni got canceled, right? Which would mean, like Clément said, that any other thing going on, like after this, would get canceled, and we would not burn CPU cycles. We would not consume scarce resources. So that's a really, really cool feature, right? And it comes from the fact that we embrace reactive principles all the way down.
So a question on that. So do the things that are occurring in the pipeline, so say you had a reactive pipeline, but you were using regular Hibernate, not Hibernate reactive. Like,
well, you probably shouldn't be doing that anyway, right?
Right, but I'm just trying to think of an example where maybe you have the thing and you're doing something blocking at some part of the pipeline. Does the things that you're doing have to support the cancellation as well?
Yeah, it has to support some kind of cancellation. So if you use a REST client or reactive SQL driver, then yes, you can cancel. Or when the protocol has support for cancellation, like gRPC or something like that. If you use JDBC, unfortunately, JDBC doesn't have that notion of cancellation at that moment. Maybe one day, but yeah. So this is useful when you are you really need to be in the reactive side of things to actually use that. But it goes with the reactive things, like you need to handle a lot of connections. So everything you can squeeze is a good thing. So if there is cancellation, you want to free the resources so you can handle even more load with these resources.
Exactly. So that was like a small thing that was useful, though, in understanding like the whole principle of why we built stuff the way we did. Okay, so let's move on to some client stuff. So here's a simple feature that was actually like really useful, and I'm surprised we didn't think about it earlier. So let's say like we have a resource, right? A resource that let's define it as like the override client, and we say here that the override client, the URL anyway, whatever, just points to something that doesn't exist, right? So does not exist.ai, because obviously .ai. So if you hit this, right, if you go ahead and hit the client, you would expect that nothing's going to work, right? Because it's hitting a domain that doesn't exist, right? Let's see that actually play out in a test. So let's see, this should throw an exception, and it does, right? We have an exception that, well, it doesn't, well, we won't see it here because this is running against the application, but the client essentially is going to get an unknown host exception, right? Which is what we expect because we're hitting something that doesn't exist. But there's this super simple feature, right? We allow you to annotate a parameter of the client with at URL, and this will essentially override the base URI for that request only, right? So if I point it to localhost 8081, this will now work, because now on 8081, we're actually starting the application and we're saying that the resource returns override. So this just works, right? I know that Max, for example, was using this to like for some like AI client stuff he was doing, and some other people in the community wanting to be able to use this as well.
And Georgios, we can see that pattern extended to other parts of Quarkus, typically
Yes.
a Quarkus function for J, where we could imagine having the model name as part of the.
We did that.
Yeah. Well, yes. Is that released? Yeah, you did a release last week. So.
Exactly. So yeah, that's absolutely right. So I think the original use case for this came from people saying, which I initially was skeptical about, but then I came around to think that this is actually good, was that, you know what, I want to use the REST client, but I don't know what the base URL is because it's given to me at runtime by like the client, right? Like the client like sends a request and that request like has the base URI in it. So then I want to use that with the REST client. I was initially skeptical. I'm like, yeah, but maybe you shouldn't be using the REST client for that. But then I came around because like the REST client is just so powerful and so easy to use. So when you go ahead and then you say to people, okay, I don't use that, but yeah, okay, then start using like the Vertex HTTP client, or start using like JAX-RS client, or like Java HTTP client, the JDK HTTP client. Those like are so much lower level in abstraction that there's so much more code you have to write, right? So I've considered actually an anti-pattern when I have to tell people like I don't use the REST client because it doesn't do that. I want to try and make the REST client like do as much as possible because it's just such a powerful tool, right? And like you said, like because we did this thing here for REST client, we've actually started thinking about using the same pattern for AI, for example, like because you guys both know really well that like a AI service, for example, is tied to a specific model, right? But what if it wasn't? What if like you could override the model name at runtime with whatever model you want, right? And now we support that using the same type of pattern. There's like a model name annotation here, and you give the model name, and then the AI service can see. And I'm sure there are other things, other places in Quarkus where this would prove useful too. So yeah, this is a pretty good. Now I'm surprised we didn't do it earlier, right? So any questions?
Nope, there's nothing about this specifically.
Yeah,
I didn't know
maybe one thing.
I learned another thing today too. I didn't even know about this.
Yeah, one thing is that do not conflate that with Stork. Stork is doing service discovery. This is selecting the URL part of your code. So it's here your code decide which URL to call, while Stork will delegate that to a service discovery mechanism. So it's not one or the other. It's actually, did you try where the URL given by the code start with Stork column / / to see if it triggers?
That's a good point. No, I didn't try that. No, that's a good point though.
My guess is though, if you did it with like an HTTP URL and you had Stork on the back end, is it would take over and bypass Stork. But if you do it with Stork : / / hopefully, it
will probably call Stork, and Stork will resolve that. So imagine the pattern you can have. You can actually switch your service discovery dynamically.
Yeah, because I know, for example, like in the superheroes, one of the services one of them we implement using the REST client, the other we implement just using like hard-coded JAX-RS, just the web client, just to show how you can do it, and just saying Stork : / delegates to Stork there. So I would assume that it would work here too.
Yeah, probably will. Okay, cool. Now, what else? What do we have next?
I like the serializers. Let's talk about. We got 10 minutes. Let's talk about.
Yes, serializers. I think that is the next one I have. Yes, I'm pretty sure it is. No, it isn't. Sorry. What is it? Yeah. Okay. The dev services proxy. Yeah, this was pretty interesting. So let's say, for example, that you have a client, HTTP client, which in this case is this one, Quarkus extension client, and what it does is that it hits a service that's behind HTTPS, right? Well, that's all great, but what happens when you want to actually like see what goes on over the wire, right? It's exceedingly hard to do tracing with Wireshark on HTTPS traffic,
Well,
right? It's very hard.
well, you need to use a hack because the
Yes.
payloads are encoded and they're
Yes,
encrypted,
exactly.
which is the beauty of TLS, but at the same time, it's pretty annoying.
Yes, it's very annoying at development time, right? It's super hard. Like for example, like when I was developing the LangChain for J stuff, right? And when you're sending a JSON request, let's say to like Claude or OpenAI or whatever, like it looks good, right? But sometimes you might have a failure that you don't understand, and if your logging isn't enough to understand what's going on, sometimes you have to drop down to the wire and see what's going on in the HTTP traffic. But if you're hitting HTTPS endpoints, which you are in the case of all the AI providers, then you're really stuck. So what we did here essentially is that we have this mode where the REST client, you can say enable local proxy true. And what this does is that for test and dev mode, it starts like a dev service essentially, which is a Vertex HTTP proxy, which runs on a non-HTTPS port, which then you can go ahead and use that proxy to see what traffic comes in and out. So let's see that in action. So let's say I have a Wireshark here, and I've started.
Can you make that a little bigger?
Not really, no.
No, you can't. So the Wireshark UI didn't change since it was named Serial or something like that before. They never changed anything.
Yes, it's the same as I remember it from university like 18 years ago, right?
Yeah.
So yeah, but essentially what I'm trying to do here is I'm only capturing HTTP traffic on my local host, right? So when I run this test, Quarkus extension test, then this client, which would normally hit the staging API of code.quarkus.io, what it does now is that it hits the local proxy, and then in my local proxy, I can see, okay, cool, it returns a JSON for me, right? And I can actually go to the JSON and figure out everything I need to. So that is super useful in debugging. And with Quarkus, like you only set like one property to make this happen. And obviously it's only for testing and production and development, right? Not for production. When, like I said, it's backed by a dev service, starts Vertex HTTP proxy, which is an amazing project, which was also described in a little bit of detail in that orange blog post we talked about earlier, right?
Yeah, so maybe this is a question of why Wireshark kind of thing. Like, what's different about that than just logging requests and responses and headers and all that and looking through it?
You can see a lot more information, right?
Yeah.
Yeah. But you can,
yeah.
okay. Yeah, go ahead.
And if you start, well, if you have big responses and things like that, or chunk responses, Wireshark will give you the thing immediately. Like logging will just be a wall of text to try to understand, oh, there is a comma missing here. Yes, it's not the same level.
Yeah,
and
exactly.
If you want to check the headers, or especially with HTTP2 with authority, yeah.
And Wireshark can also it gives you like it has this in and out arrow thing where you can like track like which response goes to which request, and you have to have nested requests, it figures it out. Whereas with logging, you're like totally on your own, right? So logging is probably fine if you have like one request and one response, no concurrency. But if you have like more stuff going on, it's just impossible to figure out anything, right? So
right,
now let's go to
5 minutes left.
Yes. Okay. So let's go to your serializers, right? Serializers. So this is a pretty cool feature, experimental for the time being. So we had our fruit resource earlier, right? So this just returns fruits. Excellent. And if you have a fruit client that gets them, this will just work, right? Obviously, because it's Quarkus, you just inject the REST client, you run it, everything works. Now, what do the reflection-free serializers and deserializers do? Well, what they do is that you're not going to see any change in behavior. Like if I run this, I'm going to get the exact same result. But what it does do under the hood is let me see if I can find the I'll have to build it, decompiler. So what it does is that it essentially creates handwritten serializers and deserializers for the POJOs that come in and out for JSON requests and responses. And it hooks those into Jackson, right? So this is a Quarkus REST Jackson specific feature, right? This only works for Jackson because we handwrite the Jackson serializers and deserializers. And let me see if I can find like what this actually looks like somewhere.
As opposed to like what Jackson normally does is it's just kind of reflection based at runtime on the fly, right?
Yes, exactly. So that's exactly what Jackson does. So Jackson works with everything, right? So what it does is that it builds at runtime. It looks at like let's say the fruit class that we're returning here. It would look at the fruit class and it would see it's a record with 2 properties. Okay, so then it says, okay, yeah, I have to create 2 fields, JSON fields, and write those out. But all that would be done with reflection. Or like, and well, it does do that reflection, but initially to figure those out, it also like has to introspect all the objects and then like cast the results and stuff like that. So it does take up more memory too. But if we use this experimental feature, let me see if I can find where the actual serializer is. Is this one it? No, this isn't it. This is it, right? So this is what the serializer for fruit would look like, right? It's just like these are standard Jackson APIs that you can use, and a lot of us have used them when we have like a more bespoke needs for serialization, deserialization. So here it just extends a standard serializer, and what it does is that it goes through each property and essentially picks up the description and the name and writes those out as string fields, right? So it writes the field name, it writes the value, and then it keeps on going. And the more, if you had more properties, it would do the same thing. If you had like nested POJOs, it would go down and do those, right? So like there's no new feature here, but what you do have here is that you are able to leverage Quarkus's build time collection of data to integrate very, very tightly with a library, in this case Jackson, which is widely used. And the result is that you use less CPU time, you use less memory because you're not doing reflection. You're just pre-generating all this stuff, and this gets executed really, really fast by the JVM, right? And this feature was
kind of like getting Avro or gRPC for regular Java and JSON.
Well,
You're thinking about how it knows how to parse the thing, and it doesn't have to figure out how to do the parsing. It knows how to do the parsing, and it's done.
Yeah, it generates, but you don't have the schema.
You don't have a schema.
Here, your Java is the schema, while in general, when you use Avro or gRPC, you have your schema written in some format, added to a registry, so you bypass that part.
Yeah.
But yeah, the code generated by gRPC, by proxy or by the Avro compiler is very close to this one. This one is actually much better. So imagine the code that is generated by the others. So yeah,
this is readable. This you can actually figure out what's going on.
Well, proxy can generate unsafe-based serializer and deserializer if you want.
Well, those are going away though. Java.
Yes,
going away. So yeah, we could this was done by Mario, but yeah, we could tell him go ahead and add this extra experimental feature, experimental plus feature that said just use unsafe and all that stuff.
No, we don't want that because
no, of course not, yeah, of course not. I'm just saying the possibilities here are it's limited by our imagination, basically, right?
And one thing, because we talk about laziness initially in this core. When you use Jackson in reflection mode, so regular Jackson, then when you hit the first request, there will be reflections, there will be things like that happening. So your memory will increase after first request, which if you are in a very capped and constrained environment can be problematic. This avoid that, because this will be known and you avoid that ramping memory that you have at that point. So it can really be a big feature if you are in constrained environment. This is, yeah, you know exactly, and you know exactly how much it will cost, and you don't have necessarily all the JVM ergonomics, like if you do a reflection call 16 times and the 17th time is slightly different and things like that, which is great when you know them, but when you don't, it can be problematic.
Yeah, so that brings up another point. Yeah, so code like this, which is like hard-coded code essentially, is a lot easier for the JVM to optimize than reflection-based code.
Yeah, that can be in line in a couple of
compiled and all that.
Yeah, so I think we're actually out of time. The other thing I had was like just showing off like the TLS stuff. But yeah, I mean,
well, who cares about TLS? Security is hard anyway.
Yeah, we all turn off security in our local environment anyway, right?
That was the whole point, that you've made it easier here. So essentially what I wanted to show was that you just go ahead and like configure, like you create like a TLS configuration for a server, for a client. Those have a name, you link the name, and just like everything just works, right? And the Quarkus CLI can generate certificates for you, self-signed certificates for you. So that's really, really cool. Anyway, maybe we need to do like a TLS specific or security configuration specific topic at some point.
Yeah, we also have a JUnit extension that generates certificate for your test. So at least your certificate for your test will never expire, because we generate them for the test. Because you can be sure that after the first couple of years of Quarkus and we started adding TLS, you can be sure that we had a flow of failures in the CI because our certificates expired and no one was able to remember, oh, by the way, how did we generate them? So, yeah. And we are adding more stuff, like Georgios is adding the certificate reloading for the REST client right now. Well, I just rejected the pull request because there is two things that need to be slightly discussed, but it will be there very, very soon. The reload is already supported for HTTP, for gRPC. I have no idea about messaging. I need to check. But messaging are very long-running connections, so it can be tricky. I need to check.
Excellent.
All right, with that, I think we're over time here. So any closing remarks? Thanks for the insights. I definitely learned some stuff here that I didn't even know, and I use this stuff every day. So, all right, I think that's a wrap here. So, thank you, Clément and Georgios. Always good to see you guys.
Thank you.
All right, and have a good rest of your day.
Bye-bye, everybody.
Bye, everyone.